Hi everyone, this is Poojitha from Sri Venkateswara College of Engineering, Department of CIC AI. Today let us see about architecture of DBMS. Now let us see about introduction to DBMS architecture. The architecture of database management system, that is nothing but DBMS, defines the structure and organization of its components. It encompasses the underlying technologies and processes that enable the storage, retrieval and the management of the data in database. Understanding the architecture is crucial for efficient database design and performance optimization. Now let us see about three-tier architecture. DBMS typically follows a three-tier architecture. Architecture consisting of the user interface, application server and database server. The presentation tier interacts with users, the application tier processes businesses logic and the data tier manages storage and retrieval. This architecture ensures separation of concurrence and scalability in larger systems. Now let us see about database storage architecture. Data in a DBMS is stored in data files, index files and transaction log files. Data files contain the actual records, index files speed up data retrieval and transaction log files maintain a record of changes for recovery. Modern DBMS may also use in memory storage for faster access to frequently accessed data. Now let us see about client-server architecture. In client-server architecture, the client applications interact with the database server to perform operations. The client sends queries and commands to the server which processes them and returns the results. This architecture allows for centralized management of data and improved security controls. The client-server model is shown in the diagram. Now let us see about distributed database architecture. Distributed database management system, that is nothing but DBMS architecture, involves multiple interconnected databases spread across different locations. Data is distributed for improved scalability, reliability and performance. Coordination and synchronization mechanisms are essential for maintaining consistency in a distributed environment. And here is an example of the distributed database architecture. Now let us see our next topic, that is nothing but query processing and optimization. Query processing involves tracing, optimization and execution of queries in a DBMS, that is nothing but database management system. Optimization techniques such as query rewriting, indexing and caching are used to improve query performance. Efficient query processing is crucial for minimizing response times and resource utilization. Let us see our next topic, that is nothing but concurrency control and transaction management. Concurrency control mechanisms ensures that multiple users can access and modify data simultaneously without conflicts. Transaction management oversees the execution of multiple operations such as single atomic unit. ACID properties, that is nothing but atomicity, consistency, isolation, durability, guide transaction management for data integrity. And here is a classification of concurrency table techniques overview. Now let us see about backup and recovery mechanisms. DBMS architecture includes backup and recovery mechanisms to safeguard data against loss or cooperation. Backup strategies such as full, incremental and differential backups are used to create copies of the data. Recovery mechanisms restore the database to a consistent state after failures or disasters. Now let us see about security and access control. DBMS architecture incorporates security features like authentication, authorization and encryption to protect sensitive data. Access control mechanisms restrict user privileges based on rules and permissions. Auditing and monitoring tools track database activities for compliance and security purposes. And here is an example of that. Now let us see about scalability and performance optimization. Scalability in DBMS architecture refers to the system's ability to handle increasing workloads and data volumes. Performance optimization techniques such as indexing, partitioning and caching enhances database efficiency. Continuous monitoring and tuning are essential for maintaining optimal performance as data and user requirements evolve. Now let us see the conclusion of our topic. The architecture of database management system, that is nothing but DBMS, includes components like the user interface, application programs, DBMS engine, data storage, database schema and data dictionary. These components work together to manage data efficiently, ensuring data integrity, security and efficient access.